Okay students, once again good morning, and this is the world of physics and you are floating with me. So today in this topic we will discuss about the Lenz formula, means how you can derive an expression for the length. Means if you have to given the distance of the object, distance of the image, then you can calculate the focal length of the lens. Or if we know the focal length of the lens and the position of the object, then you can easily calculate the position of the image formed. So this lecture is going to be very interesting, so let's get started. So here you can see the heading is Lenz formula. So first of all we have to draw a lens. So basically, as you all know that a lens has two surfaces. So let be this is your first surface and this is your second surface, and the formed lens is your convex lens, or you can say that it is a converging lens. So basically a lens has two surfaces, as I have already told you. Okay, now what, as I have explained that in this derivation there is a relation between u, v and f. U stands for the position of the object from the optical center. V stands for the position of the image from the optical center, and F is the distance of focus, or we can say primary focus, from the optical center. It means firstly we have to draw a ray diagram, then we have to derive the expression. So what should we do? Let's get started. Firstly we will draw a principal axis. So let's suppose this is your principal axis, like this way, and in this principal axis we have few points. Suppose this is your optical center represented by capital O, and this is your primary focus represented by capital F. So whatever distance is from O to F, the same distance from O to F dash, and here F dash is your secondary focus. So I hope and I believe that this terminology is now clear to all of you. Okay, now what, we have to set the position of the object. How we can put, or how can we select the position of any object? There is no any rule that in this way only you can place the object. Anywhere you can place your object. So let's suppose we put our object like this way. So this is basically your object, as you can see here, and the ray which comes out from the object, you can easily see that the ray, you can say that the ray will starts from the each and every part of the object. Okay, and let's suppose it moves like this way. Once again, okay, this is ray. So the ray moves like this way. Okay, now what, as you see here that the ray strike from the lens. Now what we have to do, again, as we know that this is the converging lens, so the ray passes from the focus. This ray will move and passes from the focus like this way, as you can see here. Okay, now what, one another ray which also starts from the object like this way, another ray, and that ray passes from the optical center like this way. So this is your ray which passes from the optical center, as you can see here. And what you can easily see that these two rays intersect to each other at this point. Okay, now what, as we know that the ray intersect to each other at a point, and that point is the point of image. So it means here we get our image. So let's suppose this is your image like this way. Okay, now what we have to do? Nothing. We can easily solve our formula, and the formula you can simply see that this is, let's suppose firstly we named it. Okay, so suppose this is your AB and this is your image A dash B dash. This is your ray diagram. Now, as I have already told you that we have to set a relation between U, V and F. So where is U, where is V, where is F? So this is your F like this way, starting from optical center. This is your V starting from optical center, and this is your U starting from the optical center. So this is your ray diagram, and I believe that this diagram is now clear to all of you. Now continue, because we have to establish the relation. So what we have to do, basically it is the relation between the object and image. In short, we can say that it is the relation between object and the image. So for that we have to assume two triangles, and the triangle must be in the same way, or we can say in that way, so that it have a similar triangles. Now what? So in this scenario, let's suppose we have triangle. First one is your triangle ABO, and the other is your triangle A dash B dash O. Means the triangle which is starting from the same point O. So the object is AB and the same point or common point is O. So your triangle is ABO. On the other hand, we have image A dash B dash and the common point O. So triangle will be A dash B dash and O. Now you can easily say that these two triangles are similar to each other. And if they are similar, then we have A dash B dash over AB, means the ratio of their heights, that must be the ratio of their bases also. So that will be OB dash, the base of the triangle A dash B dash O, and that will be OB, means ratio base of the triangle ABO. So this be your equation number first. I hope that it is now clear to all of you. What we have done up to here, firstly we have draw a image diagram, then we select a common point as O and establish the relation between AB and A dash B dash. For that we assume triangle ABO and A dash B dash O. Now we have to take another common point. And what is the another common point? That is your point F. So in this scenario we have to take object AB with point common point F, and A dash B dash with the common point F. Okay, now there is a problem here that A dash B dash F, it is clear, you can see in the diagram. This is your A dash, that is B dash, that is F. So A dash B dash F, this triangle is absolutely clear here, but as you see ABF, so ABF, it means you have to jump this length, which is not actually possible. So for that we assume here an virtual object like this way and named as MO. This is your virtual object. Okay, so that we cannot cross the lens. It means in place of AB, we can take virtual object that is MO. So MOF will be now similar to triangle A dash B dash F. I hope that this step is clear to all of you. Okay, now what? Same, the ratio of the height means A dash B dash upon MO, and that must be equal to the ratio of the base. So it is your FB dash and it is your OF. And now, as I have told you that MO is your virtual object, so in place of virtual object you can place your real object. So that will be A dash B dash upon AB, means MO, that is your virtual object, and that is replaced by the real object, and that will be FB dash upon OF. So up to here I have that each and everything is clear to all of you. Let me, this is equation number 2. Now what? As you can see from equation first and second, this is your equation first and this is your equation second. So from equation first you can easily see that one side means this side A dash B dash upon AB, and this is quite similar to the one side of equation second, that is A dash B dash upon AB. It means if one side is same, then the other side must be same or equal. So what we should write? We should write OB dash upon OB like this way. OB dash upon OB, and that must be equal to FB dash upon OF. So FB dash upon OF. So up to here each and everything, as I believe that clear to all of you. Now what? Now we have to simply put the values. What is the value of OB dash? What is the value of OB? What is the value of FB dash? What is the value of OF? So firstly we have to calculate the value of OB dash. So look here, this is your O, this is your B dash. So OB dash, this is nothing but the distance of the image, so it will be V. So put here V. Okay, and then OB. So what is the value of OB? That is your O, that is your B. So OB, this is nothing but your distance of object, but according to sign convention it should be negative. So here we put minus U. Okay, then FB dash, once again this is your F, this is B dash. So FB dash will be, you can easily calculate that FB dash distance can be calculated when we subtract V minus F. So if we subtract V minus F, or we can write V minus F, then we get the distance FB dash. Okay, so it is V minus F. So V minus F, and then O to F. So this is your O, this is F, and O to F, that is nothing but your F, focal length. So here you can put your F. So I hope each and every value is not clear to all of you. Not now. What we have to do? Firstly, we will cross multiply it. So we have VF, and that will be equal to minus UV and plus UF. Now take F one side, so VF minus UF, that will be minus UV. So if we take F as a common, so F will be V minus U, and that will be equal minus UV. Okay, or you can also write F U minus V, that will be UV. It means we have taken here negative as a common and cancelled out. So V minus U becomes U minus V, so that minus can be easily cancelled out. I hope and I believe that this step is clear to all of you. Now what? As you can see that we have result F times U minus V, so place F times U minus V, and that is equal to UV, so it will be UV. Okay, so it can be rearranged like this way, so UV divided by UV, and here you can write 1 upon F. Okay, so it can be again rearranged, so it will be U upon UV minus V upon UV, and that is 1 upon F. So you can easily see that U and U cancel out, here V and V cancel out. So finally we have result, that is 1 upon V minus 1 upon U, and that is 1 upon F. So this is your final expression, as I believe that it is clear, because each and every step I have explained to you. Okay, so in the same way you can easily calculate the you can easily derive your length formula. Length formula, once again I would like to say that this is the unique formula which establishes the relation between U, V and F. So once again, just look at this. What we have done, firstly we draw a ray diagram. For that you have to take in an object. So you got an image A dash B dash. You have to take common point as O and F. So firstly, if we take common point O, then we have to choose triangle ABO and A dash B dash O. For common point F, we have to take a virtual object MO. So MOF and A dash B dash F, and the virtual object is replaced by the real object, and in this way you can easily derive the expression. Okay, so what next now? This one you put the value, you solve it, and you get the final result. Okay, now this is your question. In this question it is given that an object of length 2 cm is placed perpendicular to the principal axis of a convex lens of focal length 12 cm. Object of length, it means you can simply that height of object, that is 2 cm. Length or height of object, that is 2 cm. And the focal length of the convex lens, that is F, and that will be positive. So positive 12 cm. Clear? Find the size of the image. It means height of the image we have to calculate. If the object is at distance of 8 cm. So the distance of object, it means U, and that is negative 8 cm. This is the basic question. Now how we can calculate the relation between height of the image and height of the object? As you have just seen here, u and f we have given. So if we see the relation, where is the relation? This one, sorry, this one. This is the a dash b dash upon ab. So it is the height of the image and height of the object, and ob dash and ob, or in place of this one you can also write fb dash upon of. So in this way, either you can use equation 1 or you can use equation 2. Let's suppose if we write equation 1. So if we write equation 1, then what should we write? We should write a dash b dash upon ab, and that will be ob dash upon ob. And a roughly diagram is here for you. This is your lens, this is principal axis, this is your object, okay? This is your image. So this is your v, this is your o, this is your height of the object, and like this way, this is your f, and the ray passes like this way, one again passes from this way, and you get your image. So ob dash is basically you have written v, and that is u, and this is a dash b dash upon ab. Now what? The lens formula, that is 1 upon f equal 1 upon v minus 1 upon u. Now place the value f. F is given as 12 centimeters, so it will be 12, and this is 1 upon v minus 1 upon, and u, as you can see that u is minus 8 centimeter, so it will be minus 8. Okay, now what? It can be written as 1 by 12, that is equal 1 upon v, and minus minus, that will be plus 1 by 8. Or 1 by v, that is equal 1 by 12 minus 1 by 8. Okay, now take LCM. Though LCM, let's suppose it be 96, so it will be 8 minus 12, that will be 1 by v. So 1 by v, and that is equal to minus 4 upon 96. Okay, now what? Take next slide, and what we get up to here, that is 1 by v. Okay, it can also written as minus 1 by and minus 1 by 24. So here v equal minus 24, so v equal minus 24 centimeter. This is your equation. First you can see what we have already derived, that hi upon ho, v upon u. So hi upon ho, that is v upon u, and v is minus 24 and u is minus 8. Okay, so that can be cancelled out, and that will be hi upon ho, and that will be 3. So now hi, so hi will be 3 into ho, so 3 and ho you can see that is 2, so it will be 2, and it will be minus 2 absolutely, so sorry, plus 2, because height of the object will be upper side. So the answer is 6 centimeter, and this is positive here. Why? Because we have, as you can see here, we have already taken the value of a dash b, that is minus hi. Okay, that's why the final result becomes positive. But if we put here only hi and ho, then we get answer as the minus 6 centimeter. Okay, so your final answer is minus 6 centimeter with sign convention, and without sign convention 6 centimeter. Okay, so I hope and I believe that this question is now clear to all of you, and we will continue this journey for you. Thanks for watching me, thanks for listening me, and just try to what we can say that this is a journey what we have started for you, for your benefits, and I believe that something should be new, something should be creative in your mind. So please, every time I request you all that don't try to cramp anything, just try to explore your mind, just try to think why these things are going on, what is going on, what is the reason behind it. Okay, so thank you very much.